It's your teacher again, Daddy Cause. And in this video, we'll be talking about preparation of acids. What are the methods available for us for preparing acids? For different acids, there are different methods of preparation. And we have three major methods employed in preparation of acids. Three methods. Number one is by direct combination. Direct combination. When you pick the element inside the acid and you react them directly, it's called direct combination. Number two is by the action of water on acid and hydride. Number three is by using a stronger, less volatile acid to produce, or if you like, to displace a weaker, more volatile acid. So we'll be discussing all these three methods for preparation of acids. So number one method is by direct combination of the elements inside the acid. This method is majorly used for the preparation of binary acids. What are binary acids? Acids with only two elements are called binary acids. Examples are HCl, two elements hydrogen and chlorine, HBr, two elements hydrogen and bromine, HI, two elements hydrogen and iodine. You call them binary acids because they have only two elements in them. How do we prepare binary acids? By direct combination of the elements inside. For example, if I want to prepare hydrochloric acid, for example, hydrobromic acid, HBr, I will react hydrogen and bromine together. I will heat them using a catalyst, in this case platinum catalyst, to give me the acid I am looking for, HBr. What is the meaning of a catalyst, by the way? A catalyst is a substance which speed up the rate of a reaction. Some reactions might be very slow even after you have you eat them. But when you add a catalyst will make the reaction to be very, very fast. So a reaction that would have taken about 10 hours could happen in 10 minutes with the use of a catalyst. So you define catalyst as a substance which speed up the rate of a chemical reaction. Let's see hydrochloric acid also. How do I prepare it? Since it's a binary acid, I'm going to directly react the two elements together. When I react the two elements together, I'm going to use a catalyst here, but in this case, I'll be using activated charcoal catalyst. Then I also need to heat the two reactants together to give me the acid. So you call this direct combination because I'm reacting the two elements inside the acid directly. That's direct combination. Let's look at the second method of preparing an acid. It's called action of water on acid and hydride. When you dissolve acid and hydride in water, they give you acid solution. What are acid and hydride? Acid and hydride are oxides of nonmetals which dissolve in water to form acid solution. Oxides of nonmetals. Nonmetal like sulfur, nonmetal like carbon, nonmetal like nitrogen. Their oxides are known as acidic oxides, or if you like, acid and hydride. Let's see example of acid and hydride. SO2, that's oxide of sulfur, sulfur 4 oxide. Sulfur is a non-metal the oxide of sulfur will be acid anhydride. They can dissolve in water, and when they do that they form acid solution. See, SO2 dissolve in water giving you H2SO3. See, H2SO2 plus 1 making 3. That's how you form that acid. So by dissolving acid anhydride in water, you get that acid. Another example of acid anhydride is SO3. When you dissolve it in water, it gives you H2SO4. See, SO3, just add the H2 and add the oxygen here. That gives you H2SO4. So it's an acid anhydride of H2SO4. So sulfur alone can form two types of acid anhydride: sulfur 4 oxide and sulfur 6 oxide. Other examples of acid anhydride are CO2, carbon 4 oxide. Carbon 4 oxide can dissolve in water to give you H2CO3. CO2, when it dissolves in H2O, it's going to give you H2CO3. H2CO3. Another example of acid anhydride is NO2. NO2 is nitrogen 4 oxide. Now, it is a special type of acid anhydride because it can form more than one acid when it dissolves in water. So because of that, you call it a mixed anhydride. When NO2 dissolves in water, it forms HNO2 plus HNO3, that is dioxynitrate 3 acid and trioxynitrate 5 acid. Two types of acids, mixture of two acids when it dissolves in water. So that's why you call it a mixed anhydride. So that is how you produce acid, by dissolving the anhydride in water. The last method of preparation of an acid is by using a stronger acid to produce a weaker acid. A stronger acid that is less volatile. By less volatile, we mean that the acid has high boiling point. If you say more volatile, it means it has lower boiling point. Volatility is like opposite of boiling point. The higher the volatility, the lower the boiling point. When you say that a liquid is volatile, it means it can easily escape from a surface, and that means the liquid has a low boiling point. So if I say a less volatile acid, I'm talking about an acid with higher boiling point. That's the last method of preparing acid, and in this case we'll be particular about concentrated H2SO4, that is conc acid. Is the strongest of all the acid and has a very high boiling point. So because of that, we can use H2SO4 to produce other acids from their salt. If you heat conc H2SO4 with the salt of other acid, it's going to displace those acids and form them because of its high boiling point and because of its strength. It's very, very strong and has a high boiling point. So when a chloride salt is heated with concentrated H2SO4, hydrochloric acid will be produced. See that a chloride salt like sodium chloride, when you heat it with H2SO4, because because chloride salt is a sort of HCl, it contains chlorine, and there's chlorine in HCl. So when you heat H2SO4 with a chloride salt, NaCl, KCl, hydrochloric acid will be produced according to this equation. NaCl plus H2SO4, then see what happens. The Na pick up the SO4, that gives us Na2SO4. You know how to do that. The valency of Na is 1, valency of SO4 is 2. So that will give us Na2SO4 when you exchange their valencies. Now what is most important to us is H and Cl combining to give us HCl. So you can see now that in this equation now, H2SO4 is behaving as a strong acid and as an acid with high boiling point. If you want to produce HNO3, then you will heat the H2SO4 with a salt that has NO3. You call them nitrate salt. Nitrate salt. For instance, when you heat H2SO4 with nitrate salt, you are going to form trioxonitrate 5 acid, HNO3. According to that equation, KNO3 plus H2SO4 is going to give you K2SO4 plus HNO3. Look at that. See the chemistry behind that reaction. K picks up SO4, giving us K2SO4. Valency of K is 1. Valency of SO4 as a radical is 2. So when they exchange their valency, that gives us a K2SO4 1. So that is why we have K2SO4. Then the remaining is H and NO3. Valency of H is 1. Valency of NO3 2 is also 1. So when they react, when they combine, they give us HNO3. In this case, we'll be having 2 mole of HNO3. 2 mole of HNO3 and 2 KNO3 in that place. So that is how we use a stronger, less volatile acid to produce a weaker, more volatile acid from its salts. Let's see some confidence building question before we are going to end our discussion on acids. Number 1, which of the following is a binary acid? H2SO4, HNO3, HCl, or H2CO3? Which of them is a binary acid? That's question number 1. Question number 2, which of the following is an acid anhydride? You remember how to define acid anhydride? Is it CO? Is it SO3? Is it H2O? Is it N2O? That's question number 2. Which of the following is a mixed anhydride? Is it NO? Is it NO2? Is it CO? Is it N2O? You are going to find answers to all these questions in this video that you have watched. So that's our question number 3. Question number 4. Which of the following is the anhydride of H2SO4? Is it SO2? Is it SO3? Is it SO4? Is it S2O3? Which of them is the anhydride of H2SO4? That's our question number 4. Let's see question number 5. Which of the following is the anhydride of a weak acid? That is, when the following acid dissolves in water, which of them will give us a weak acid? CO, SO3, CO2, N2O. Which of them is an anhydride of a weak acid? Finally, before we end the class, what property of H2SO4 enable it to produce HCl? Is it because of its oxidizing power? Is it because of its dehydrating power? Is it because of its boiling point? Is it because of its reducing power? Don't forget that in this case now we are using H2SO4 to produce HCl. What property will H2SO4 have that makes it to be able to produce HCl from all these options? are using is you are using H2SO4, a very strong acid, to produce HCl, though strong acid but weaker than H2SO4, then what property of H2SO4 does it enable it to produce HCl? So here, what property is shown by H2SO4 in the equation below? You see the equation NaCl with H2SO4 to give us Na2SO4 plus HCl. In this place, HCl is actually produced from NaCl by reacting with conc H2SO4. So that conc H2SO4, what is it behaving as? Why is it able to undergo this reaction and produce HCl from NaCl? Is it acting as an oxidizing agent? Is it behaving as a dehydrating agent? Is it behaving as a strong acid? Is it behaving as a reducing agent? That's our question number 7. Which catalyst is used when hydrogen gas combines with chlorine? In this video we look at how HCl is formed by direct combination. In that equation, that reaction, which catalyst is employed? Is it platinum? Is it activated charcoal? Is it palladium? That's our question number 8. Question number 9. Binary acids are produced by what? Is it by dissolving acid anhydride in water? Is it by displacing a weaker acid by stronger acid? Is it by direct combination of constant elements? Is it by neutralization reaction? That's our question number 9. So we look at some essay questions before we go. Number 1 essay question: what is a catalyst? What do you understand by a catalyst? Number 2 essay question: what are acid and anhydride? Number 3 essay question: name one element which has 2 acid and anhydride. That's question number 3. Question number 4: write the IUPAC name of a mixed anhydride. What is the name of a mixed anhydride? Question number 4. Write the anhydride of the following acid. Question number 5. H2CO3. What is the anhydride? HNO3. What is the anhydride? H3PO4. What is the anhydride? H2SO3. What is the anhydride of those 4 acids? Write the anhydride of the following acid. We have talked about that. That's our last question in this video. And with this, that will be the end of acids. Our next video will be starting with bases. Leave any question you have for me in the comment section and I'm going to answer it. God bless you.